Say that for legal reasons. All right. So can you see the title slide?
Yes.
Yes, sir.
Good to see. Again, I'm asking if anyone's coming in from the classroom. I actually did have an email from a student who's a commuter and was wondering how he could connect in, and my suggestion was connecting in from the classroom. Let me see if I can see who that was. Okay, that was Jaden Tipton. Jaden, are you online? Oh, no, I'm sorry. That was for the operating system class. So that's not until the next one. All right. So I am recording this and I will post it on YouTube so you can see the lecture if any of the students that missed want to see it, or if you want to see it again. I don't know how exciting it is that you'd want to see it again. One thing that came up, well, let's do the devotion first, and then I'll go into some topics. So. Sorry, getting situated here. There we go. Okay, our devotion for today is Luke 6:32 through 38. If you love those who love you, what credit is that to you? Even sinners love those who love them. And if you do good to those who are good to you, what credit is that to you? Even sinners do that. And if you lend to those from whom you expect repayment, what credit is that to you? Even sinners lend to sinners, expecting to be paid in full. But love your enemies, do good to them, and lend to them without expecting to get anything back. Then your reward will be great, and you will be children of the Most High, because he is kind to the ungrateful and wicked. Be merciful, just as your Father is merciful. Do not judge, and you will not be judged. Do not condemn, and you will not be condemned. Forgive, and you will be forgiven. Give, and it will be given to you. A good measure, pressed down, shaken together, and running over, will be poured into your lap. For with the measure you use, it will be measured to you. So does anyone have any thoughts on that? Let me bring up the chat window. But yeah, if you could unmute your microphone and speak, that's the easiest, but you can chat as well. So anyone have any thoughts about these particular verses? And in particular, do you find this easy to do? Anyone have any thoughts? Okay, well, the thing that strikes me about this particular verse is it talks about how we tend to be kind to people who we can expect something back from, or people that are like us. There are people in our life that we often considered extra grace required, but do we go that extra mile and to be friends with them, even though they're people that we don't necessarily connect with or even have good feelings about, but we are held to be kind. In verse 37, it talks about not to judge, which is a very difficult thing to do. We do have a tendency to make decisions about people and judge their actions. And the truth of the matter is we don't know what the other person is going through. But the other thing is we are just called not to judge. And in verse 38, that says the rewards are immeasurable for doing this, of going out beyond people that we're comfortable with, and basically being kind to them. And now you don't necessarily have to be best friends, I don't think, but certainly there's his word says that we want to be kind to everybody. So, all right. So I'm roughly quickly doing roll here, and I see Timothy is missing. Is that correct? Timothy's not online. And then Caroline, I don't see here. And then Samuel and Nathan. Yeah, I'm fortunately with this switch to online, I'm afraid we might have lost some people, but I'm hoping not too many. But if you see any of those students, let them know that I'm planning on putting it online, and anyway that they can see a recording of the class in the class notes. And plus in the module sections, you can see the slides, and I will put up the administrative slides as well. So just administrative items again. Your acceptance of syllabus is due by Monday. There are still a few students that have not accepted the syllabus. So Monday is today. It's due by midnight tonight to get the 1 point. And then there will be a quiz on chapter 1 this coming Wednesday. Now I noticed that the room next to us, 134, is available. I would recommend that you either bring your laptop or get Canvas Student, the app Canvas Student app, and put it on your phone. But my plan is to have a little field trip to room 133 because it's open and there are computers that we can use there for you to take the quiz. So that's my current plan. There's nothing scheduled there, and I don't haven't typically seen any other classes or anyone else using that room. So that's the plan, is to move to there. The other thing is we have an assignment, which is a project. I mentioned that we will have a programming project in class, and right after you do the assignment using .NET, we will start having people present their proposals of projects that they'd like to work on. We'll take votes and form teams to work on these projects. So this is where you get to put into practice some of the things that I'm hoping you're learning from class. The really correct way to learn the concepts of software engineering is to practice it, because when I, as much as I talk about these particular topics, for it to really hit home, you need to actually dive in and try to use some of these concepts. So this will be your opportunity. The other thing that has come up is I just want to make sure everyone knows that I'm not Dr. Lim. I don't have a PhD. I have a quick overview of my history. I have a master's in computer science, but no PhD, and actually no plans to pursue a PhD right now. My free time is spent dawdling over my grandchildren. We actually have 2 of my grandsons living with us right now. But my main experience is I have spent 35 years as a software engineer, computer scientist / computer scientist in industry. I spent roughly 25 years doing research and development programming for the national labs at Lawrence Livermore National Lab. And then roughly the last 10 years, I spent in the medical device industry, in particular optometry and ophthalmology. So that's just, I'm not saying that these are wonderful experience. Well, they're wonderful experiences, but wonderful criteria for you to be listening to me. It's just sort of a perspective of where I'm coming from so that you can use that as your filter to filter what I'm teaching, and you can see where my biases and experience are coming from in teaching this class. So any questions about the assignments and administrative stuff? So yeah, start thinking about what kind of project you'd like to propose for the class. All right, so moving on. Oh, here it is. Okay, can you see my slides there?
Yes.
Great.
Yes, sir.
Good. All right, so let's see, what did I say? We were in slide 10? Yeah, slide 10. All right. Okay, so let's see, I'm going to go back one slide. So we did estimating effort and we did testing. So in this next slide, the slide that we're going to start covering is on implementation. But one thing I'd like to emphasize is that testing and implementation should go hand in hand with each other. We have unit testing, which is very important, and black box testing and white box testing. So who could hazard a definition or would like to hazard a definition of what's involved with white box testing? What kinds of information is used to create white box tests? Oh, wait a minute. So I go ahead and answer, and I actually have a message from someone that says that there's no one here.
I'm assuming the source code.
Yes, so that's right. So what else is involved with besides the source code?
Didn't you say that the user has access to the design and implementation of the code?
Yeah, they have access to the design and implementation and of the code, but also in addition, you do have black box testing has access to the requirement specifications. So does white box testing. So it's really additional information is available beyond black box testing. You have the requirement specifications, the design, and the implementation. So good, exactly right. So very good. You were following pretty good. So coding implementation. So some of the things that we look for in coding implementation to improve the process of working as a team, and this is very important. Most of the time you'll be working as part of a team. Here are some guidelines that of things that are important for code implementation. So this is important. Please remember this slide and focus and study this slide. So consistency, typically there are project or even company-wide coding style guidelines. This is to make the code look the same or similar so that it can easily be handed off between individuals. Now we have something like that we call coding style religions, and that is people generally have a personal programming style preference, and it is bad if we have everyone programming in a different style within a group project. So typically what you do is either as a company-wide decision or at the beginning of a project, you sit down and you decide and agree to what the coding conventions are, because it can wreak havoc. Not only is it hard to pick up someone else's code that's written in a different style because you have to reorient yourself, but you do have individuals that have a tendency when they go in and look at someone's code, if it's not in the style that they enjoy or like, they will actually go in and modify the other people's code to match the style of coding that they like. This creates lots of problems, as you can imagine. It's, first of all, a waste of time, use of time that could be more valuably spent on actually coding rather than changing the format or the of the code. And the other thing is when you check in the code, so we have a code repository, it shows the changes in the code. And that's valuable in that you can go back through the change history of the code and see where things have been changed to try when you're trying to trace back a defect and see what happened. You can see the changes that happened and around the time that the defect appeared, and get an idea of what coding change may have induced a defect if it wasn't in the code before. But if people are changing the code based on to change the style, all of a sudden you got all these superfluous changes that have to be waded through when you're trying to evaluate changes in the code, because really they're just stylistic changes. They're not actually coding changes, hopefully not coding changes. And again, it makes the job of tracing down defects much more difficult. The thing that I referred to in, and this is important, about tracing back through code and seeing where changes are made and where a defect could happen. Why did you suppose you can't just take advantage of your unit tests to pinpoint what function an error can happen? I mean, certainly that is one source of detecting where a defect is coming, but why else? What else may be involved that would have you going back through the change history of your repository, of your storage of code, looking for other possible changes? Anyone have any ideas?
Another person working on a different part of the code may have changed something that you didn't realize when you were working on your own part?
Yes, essentially you've got it right. And I will rephrase it in that when there's an error in a particular method or function, the cause of the error could be external to the code where the error occurs. We will learn about contracts, where a method will have a contract and it will have generally a contract about what kinds of inputs are required and what kinds of outputs are expected, and what kinds of preconditions and post. Basically, what I'm talking about is preconditions and postconditions that are that specify the contract for this method. And it is quite possible that the error could have been in a particular method be induced by code outside of that method or that section of code. So that's important to realize, and I think you may have run into this already in your programming, is that the source of an error, even though it appears to come from a particular location, could come from anywhere else, anywhere in the code. So I am going to take a quick break, and I respond to a student who says that they did not notice let's see, I'm going to forward him the email that I sent, and hopefully he'll see it. Sorry about this delay. Here we go. Let's see. Okay, let's see if I can get this cut and paste to work. All right, sorry about the delay. So anyway, going back to my presentation, I'm definitely interrupt driven right now. All right, so I assume you can still see the presentation.
Yes.
Okay, good. So that is why having coding conventions and consistency in your code is important. There are many other reasons as well, but those are the main reasons. The other thing is choice of names. They should be very descriptive and easy to name. So one of the things about choices of names to make your code self-descriptive, which I think you're all aware of from your other programming classes. One of the things that I've noticed, and I think your textbook calls out as well, is oftentimes if you have some variable that you're having a hard time coming up with a name for, oftentimes that's an indication that your abstraction is wrong. If you have some object or some value that you can't come up with a name for, maybe you're looking at the wrong, your object is defined wrong or abstracted wrong, or the variable that you're trying to store is not what you should actually be storing. You should be storing something else if you can't name it. So that's sort of a indication if you can't come up with a good name for a variable, that you may have a mistake in your design. You might have a shortcoming in your design. So another kind of rule of thumb is generally names that have more global scope, like method names and class names have more descriptive names than, say, just a local variable within a method. There you can use still descriptive names, but shorter names because within that method there is localized in scope, and certainly typically loop variables will be something simple like I and J, because loop variables are pretty much well understood unless there's something specific you want to convey about what the index represents. So that's sort of another rule of thumb for naming variables. Generally more globally scoped, or things that are referenced from outside of its local code, will have longer and more descriptive names. And then test early, and I would include test early and often, because again, finding errors early makes it a lot easier to bug and discover where an error occurred. You're also fresher in that particular section of code, and also like I said, you can have situations where errors are induced by some other method, and so that will allow you to focus on those cases where you're integrating methods and be pretty confident that your method is probably right. You still have to check it, but gives you a clue that it may be time to start looking around about who's calling the method, or what other things have changed around it. So this idea, like I said, of integrating implementation and testing is very important. There is a methodology called extreme programming, XP for short. which actually advocates that you write your unit tests, your test codes, basically white box testing before you actually write the code itself, which seems kind of backwards. You would think, oh, I write the code and then I'm going to write the test code to test that code. But they actually advocate that a better way to do it in terms of its efficiency and getting the code written correctly is to write the test code first and then write the code, constantly run it against your unit tests to see if it's actually passing your unit test. So that's just one thing to keep in mind, and it's a very important distinction that extreme programming has, is that they do test what's called test-driven implementation, where their implementation is actually driven by testing. So please keep that in mind. The other thing is use standard libraries. Do not reinvent and re-implement the wheel. There's less work, less error-prone, and more understandable. So standard libraries are well tested. They're used by lots of people. And you don't want to reinvent the wheel, because the truth of the matter is there's a high probability that you will make a mistake in reinventing that wheel. So you don't want to do that. Certainly in some of your programming, software programming class, introductory computer science 1 and 2 classes, you learned about different data structures and standard library things that you actually implement, like trees and things like that, manually, so that you can better understand the data structures. But keep in mind that most languages have these data structures and operations and methods to manipulate these data structures. And so in the real world, you would not write your own implementations of, let's say, a stack or a queue, etc. That's just a programming exercise that you used in your software computer science 1 and 2 classes, that you in fact would use an existing one. And I certainly have seen the case where someone actually did not use a standard library. It was actually a data structure that have to be synchronized. And this individual, not realizing that the language libraries automatically supported synchronized versions of the data structures he was trying to use, tried to implement them himself and created a real mess. So this is very important to realize. The last coding implementation we have here is code reviews. And code reviews are basically getting together a group of team members or even people in your company outside of your team to review a section of code before you commit it. This is an invaluable tool for making sure that your code is well implemented. It is in particular comes into play towards the end of a project when you're trying to squash those last few bugs and put fixes in. As you do a code change, as you're getting ready for a release to fix something, generally it would be required that you actually have someone else do a code review of your change before you commit that to the source code repository. And that's because we want to make sure there's as many eyes as possible on that piece of code, since you're getting close to the end game, so that you know that that you're not inducing another error. So who else can think of another advantage of having code reviews, where either an individual or even sitting in a meeting room, multiple or even the whole team reviews a section of code? Can anyone think of another reason why a code review would be beneficial? Well, certainly there's the obvious one, which I've pretty much already talked about, in that more heads are better than one. So having other perspectives, eliminates errors and introduces other possibilities of how the implementation, and you also have design reviews as well, or design could be implemented better. What else? Anyone in terms of a team, company atmosphere?
I guess it would help like with the consistency and stuff, so everyone would know what's going on and no one would try to change it or anything later on.
Yeah, that's good. So someone can point out that if the coding standards are being used and seeing what other people's code looks like so that they can use that as model for their own code. Yeah. That's a good one, Joseph. Or do you go by Joe or Joseph?
Joseph.
Okay. That was a good one, Joseph. So the other one, which is what I was actually thinking of, is it actually forms a form of cross-training. Now you have other members of the team that are aware of what this particular programmer is doing. So that if he all of a sudden decides to go to take a job at another company or take another position within the same company, all of a sudden you now have people who are aware of what this programmer is doing, at least at a superficial level, but some level of understanding of what this programmer is doing, so that if he has to fill in for them, for instance, like me, where I've injured my foot, all of a sudden I'm out. What do? You need, if I'm on a critical path and have critical things that I'm working on, you want to have people that are aware of what I'm doing and that will be able to step in and fill the gap. So that's another reason. So any questions about that? That's the last slide for creating a program. So again, there will be a quiz on chapter 1 in this chapter on Wednesday. And I did have a student, and I'm hoping this is true for you, that said, actually, if you're paying attention in class, the quizzes should be easy. And I'm hoping that's the case for all of you. Okay. So moving on. All right, can you see that slide?
Yes, sir.
Great. Okay, so we are now moving beyond just creating a program using good software engineering techniques, but we're moving on to what the text refers to as building a system. Okay, so what is the difference between writing a program and building a system? The big difference, which is kind of talked about in the rest of the bullets here, is the huge increase in complexity and size going from a program to building a system. The system is generally thought of as a much larger piece of code. And typically it's large enough that you have multiple people working on it at the same time. So first of all, you do have the complexity of a larger system and much more complex system, but you also have the complexity of the fact that it's not possible for, in the time being allowed for this particular system, for a single individual to write the program. So we actually need a team involved, and the intricacies of managing a team and coordinating a team to work on a project is much more difficult. So This slide basically points that out. There's complexity in slide, and we talk about here in this slide the breadth of complexity and the depth of complexity. So those probably sound like rather strange terms to you, but they are terms that you will hear in a conversation with fellow software engineers. So the breadth of complexity is the sheer number of methods or the sheer amount of code that you have. As the code gets larger and larger, you just have a lot of code. So that is what is referred to as the breadth of complexity. So the other one, in contrast to the breadth of complexity, is the depth of complexity. So who would hazard a guess of what the depth of complexity is?
Would that be just like, you know, how complex the actual code is or how complex the problems you have to solve are?
Yes. So that, Alex, that is exactly right. So how complex are the methods that we're doing? How complex are the concepts that we're trying to solve? How complex are the algorithms? But the other thing that's involved with the depth of complexity is the interaction between all these methods. So now you have all these methods, and you have all these methods interacting with other methods and other objects and other parts of the system. So you have all these tentacles of interactions that a particular piece of code is now interacting with because of the size or breadth of the complexity. But there's also depth of complexity involved with that because now you have all these pieces of software that need to interact with each other. So that's what's referred to as the depth of complexity. But thank you, Alex. That was exactly right on the depth of complexity. So here again, there's just basically more and more complexity everywhere in the system. This is just sort of a diagram that I think I've stole from the text that says that you have a problem that's of great size and complexity, and you now have to transform it to a solution. That effort, because of that breadth and depth of complexity, and is much more difficult to make that transformation. Again, these are things that we already talked about. More functionalities are involved. So that means your software is required to do more things. There's more things involved. And then within those particular main pieces of functionality, there's more features within that particular area of functionality. So an area of functionality may be backup. So you need to be able to back up your data and recover the data if there's a failure, for instance. And there may be all kinds of features involved with that, in that you can actually export those backups and store them on external media. You can actually use that to transfer that backup to a thumb drive and take it over to another machine. And there needs to be a way to track that. Those would be all functionalities that would be involved with backup of data. So there's a particular piece of functionality that you need to be able to back up your data to prevent loss of data. But then within that backup functionality, there's all kinds of various features that have been tacked on to that area of functionality. There can be a variety of interfaces, both internal and external. So typically on a large project, you will have your system divided up into subsystems, so various components and subsystems, in order to structure your code in an efficient way. And you can think of interfaces that have to be defined between these various subsystems. And by the way, the interfaces in such a large system are crucial to have well-defined and well thought of and agreed upon i.e. there should be a review by a large group of people to make sure that interface is correct, because that becomes your contract. And a large source of errors in a particular piece of code happens at that interface, where there's a mismatch in what one subsystem thought the interface was defined as versus another subsystem. And so that's why it's important to iron out what these interfaces are, because it is a large source of errors, is this interface. And of course, we have here external interfaces. That's going beyond just a subsystem of the system we're making, but it could be a completely external to this project interface of another system that we need to access. An example of this is, say you have a shopping website and you need to be able to allow your customer to purchase something, and in particular pay for something. So there you have an interface with, say, the credit card companies and PayPal and things like that, where there's a particular interface that is being used for your customer to pay for a product that they're purchasing. That would be an example of an external interface. So something that's completely external to your project and possibly external to your company's, all your company's software could be an external interface. The other things that adds to the complexity is that you will have many more and different types of users using your system. If you're having have a simple program, typically you only have a single user or a very small set of users, whereas in a large system there will be many users and many types of users. I mentioned before, one project forgot that IT was a customer of their particular project in my software engineering 2 class. So that's another level of complexity that makes doing a complete system or project much more difficult than a single program, a simple program. And then we just simply have more data, variety of data and data structures, which means that you need to define your data structures, a lot more of them. You have to keep track of them. And in particular, this is another thing that you want to iron out, is your data structures, especially when you have a database involved. You want to have your database schema, which is how you're going to store the data in the database, well defined out, because what happens if you don't is you get your product, say it works for this particular release of a software, and you get it out in the field, and then all of a sudden you realize, oh, wait a minute, our schema is not quite right. We should have probably done it this way. Now it becomes a much more difficult problem, because you have to migrate your existing customers' databases schemas to the new schema if you have to change it. So again, these are all things that you need to think about on a large project. This is something that I think discussed in the previous slide, where I introduced the idea of complexity. Any questions about this? So one thing on this slide is a new term that I've introduced. Well, actually, there's multiple new ideas. One is data sharing. That's pretty straightforward. Control passing means who's in control of the software and who's dictating the flow of the software at a particular time. That's where we'll get into what a software manager is. And basically the role is, the software manager is the person who adjudicates where things are going. And you want it to be centralized as much as possible. There may be design reasons why you would distribute it, but in general, you want it to control for particular pieces of functionality to be controlled by a central manager. Otherwise, you have havoc in your system. And I have seen systems fail because more than one section of code thought it was in control of the control flow of the program, basically the workflow, and all of a sudden the two would get out of sync, and then really bad things started happening, and it introduced a lot of errors that were hard to track down. So that's sort of a quick overview what control passing is and why having various managers involved with controlling is important. And then we have the concept of coupling, which coupling is basically the dependencies between methods. So it is the depth problem. It's you want to reduce the amount of coupling between systems because it does make it as hard as possible. So one of the design goals is to reduce that amount of coupling a particular method has with other methods as much as possible. You want to, you can't get rid of it completely because that's sort of the whole point of methods is so that they can be used by other areas of code, but you want to keep it at a minimum. The flip side of coupling in here is cohesion, and cohesion says a particular method is doing one thing and one thing only, that it isn't trying to do multiple things. If it is trying to do multiple different things, that's an indication that that method should be divided up into multiple methods so that that method is explicitly doing doing something very specific and not doing things all over the place. And frankly, trying to name a method that has poor cohesion would be difficult because all of a sudden the name of the method is this and this and this and this. It's like, oh, wait a minute. If that's what the name of this method should be, then maybe this should be more than one method. So that's coupling and cohesion usually go hand in hand in terms of discussion and design. So I pretty much threw a lot of stuff at you, but here's an important slide that you should keep in mind and focus on is how do you handle complexity? And the key thing to remember is it's by simplification. We do use various techniques in order to try to minimize the complexity as much as possible. We try to make it look as simple as possible. This is done by the techniques of decomposition, breaking the solution into smaller problems. So now you just need to solve a bunch of smaller problems and then integrate them together. Modularization of the solution is creating different modules of your solution, very similar to decomposition, but it's the modules of the solution, and that you have various methods and objects, for instance, in your solution, and those become your major modules. We also have subsystems, another form of modularization that I talked about. And then we have separation of concerns, a problem and a solution. Here, you're trying to separate the problem from the solution to some degree so that it can be easily modified on the fly if you get it wrong. And then we try to incrementally resolve problems, and we'll get into this. There's various methodologies that tackles the solution of solving a problem in stages and building upon those stages in order to come up with the final solution rather than trying to tackle the whole solution as a whole at once. And so these are all areas that can be used for handling the complexity. And please remember and know well what these areas of these techniques, categories of techniques that are used for handling complexity are. So any questions about what we covered today or the class in general? All right. So again, my plan is to be in class, in person, again on Wednesday. I apologize for this little curveball. It just kind of came up with my foot. But again, I will post the lecture material is already on Canvas, and the recording will also be available on YouTube, and I will send a link to that to everyone, to that YouTube link, and I will post my administrative slides. So anyway, you're dismissed, and have a great day, and I hope to see you in person on Wednesday.
Thank you.
Thank you.
Thank you, Mr. Lim.
You're welcome.